A CFO stares at an invoice that makes zero sense. The projected software budget for the quarter didn't creep up, it tripled overnight. For the last 10 years, financial leaders have built their models on predictable, flat-rate subscriptions. You pay a set price per seat, and your operational costs are locked in. But AI agents don't use software the way humans do. An agent is an autonomous worker, executing document pipelines and internal queries continuously. And an agent doesn't sleep. You are suddenly paying for raw utility consumption by the millisecond. Applying traditional software math to autonomous utility consumption makes the actual cost difficult to predict and nearly impossible to budget. When that massive bill hits the desk, the initial leadership reaction is highly predictable. Find a cheaper model. This diagram shows the exact calculation they rely on. The math looks beautiful on paper. The cost drops from an expensive $2 on a premium model down to a budget rate of 28 cents. That single switch pushes a projected $40,000 monthly operating cost down to a manageable $3,000. Engineering gets the memo and simply swaps out the API endpoint. Leadership walks away confident they've secured their margins. But optimizing exclusively for a low unit price creates a dangerous illusion of savings. It ignores how the system actually operates in the real world. The first crack in that spreadsheet appears as a hidden cost, the reliability tax. Budget models struggle with complex reasoning tasks, meaning they fail frequently. Look at how this pipeline functions. When a request fails on a cheap model, it automatically retries on a premium model. The compound is brutal. You pay the cheap rate for failure, the expensive rate for success, plus engineering labor to debug. A token that looks 10 times cheaper up front ends up costing 4 more if you have to buy it twice just to get a single usable output. The initial assumption is that one user prompt equals one API call, but that ignores a structural mechanism called agentic fanout. This diagram illustrates how autonomous agents actually work. An agent breaks a complex problem down into dozens of simultaneous subtasks, taking that cheap 28-cent base rate and multiplying it across a massive web of interconnected calls. Then comes the second multiplier, context bloat. To get accurate answers, the AI needs to be grounded in your historical documents and past conversational history. This visual demonstrates the strain on the system. Every time the AI references that past data, it has to reread the entire document file. This bloats the amount of data processed per call, inflating your costs by 10 to 40 times. Poorly managed context and fanout turn a small request into a high-volume data event, leaking the budget through the architecture itself. Back in the boardroom, leadership hits a wall of disorientation. Hidden architectural variables have completely hijacked the budget, and executives are suddenly fielding intense questions about latency and system stability. In fields like healthcare, finance, or government defense, strict data privacy and compliance constraints filter the menu of available models before price even enters the conversation. When leadership forces an engineering team to use a budget model that violates these constraints, they accidentally turn their highly paid developers into a manual quality assurance department. Measuring financial success by the price per token is the wrong unit of measurement. The only predictable financial metric that matters is your overall cost per successfully completed task. It's the kitchen, not the menu. The design of the system carries more weight than the unit price of the model. A premium model within a precise architecture can consistently outperform and outsave a budget model in a disorganized one. For your next budget meeting, leave the invoice at your desk, bring the architecture, and audit the system.